This video lecture is about SQL data manipulation language, in particular the subquery feature of that language. The major source of the material is the textbook, section 3.8. As well, you will wish to read the MySQL material on subqueries and also with, which is also referred to as Common Table Expressions, or CTE. I mention that because if you try to look it up, because you can't find the reference, Common Table Expressions is the term to look for. Cross-reference material for this is the work on relational algebra. There are four broad categories of subqueries in a language like MySQL or a system like MySQL. They refer to only the first three as subqueries. Technically, with is also a subquery. The textbook places with in the same category, but they're in a separate section within the textbook. The first three main categories are referred to based on the part of the select query they come from. So if we think about a select query, it is select something from something where something. So category 1, the subquery is in here. Category 2, the subquery is in here. And category 3, the subquery is here. The with statements are a new convention. They come before the select statement. I say new, they're about 20 years old. The with statements are essentially a form of modularizing SQL and providing the equivalent of the relational algebra temp variable. Okay, we will start by looking at the first category, the select subquery. So the subquery is in the column portion of the select statement. One or more of the columns or a portion of the columns. Okay. It doesn't have to be the whole of the column is selected can be a subquery. In fact, in the example I'll show, it is a portion of the column. These are typically used to blend aggregate and non-aggregate data. I don't want to say that that's their only use, but that is indeed the most common use for them. So, by way of example, let us find the ratio of a professor's salary to the average salary. This is not a query that can be done without some mechanisms such as subqueries or joins. In particular, the average salary is an aggregation operation, and because it is an aggregation operation, it takes the original table and reduces it. So we have the original instructor table. It's got an ID, a name, a department, and a salary. Okay. Department, name, ID. So the aggregation query average is going to take this and it's going to produce, in this particular case, a single number, which is the average salary, whatever the average of this is. Call it 68,000 for the sake of argument. If we have our query select average salary as AVSal, then this column will be called AVSal. If we don't give it a name, it'll just be referred to as average salary. Okay. From instructor. Okay. As soon as we have done this, the select average salary from instructor, we've reduced it down to this. The name is gone. There is no name available to us. If we select the name and the average salary, we've now got a different problem. Okay. The different problem is, the problem we now have is we have an aggregation with a non-aggregated column. We need a group by, because average salary is reducing it down to this. A select name average salary is going to give us a relation with name and average salary. Okay. We can't have one number in here, so we've got to have a number of numbers, one for each name here. And we have the average salaries. What are we going to group by? Normally we'd group by name. The problem with group by name is, let's say we've got 2 Professor Joneses. Okay. Then we would wind up with 1 Professor Jones here and the average salary of those 2 professors. Okay. But it doesn't really matter. None of this is helpful because it's not giving us the average salary of all instructors. So if we go back here, we need the average salary of all instructors. We do that as a subquery. The second column in our table, salary, the name, and then the salary divided by this average salary. And I'm renaming it a salary ratio. So the result will be name salary ratio, and this will then be each name and then the associated ratio. So let's say Einstein earns 100,000 and the average salary is 50,000. We'll have Einstein in here and the ratio would be 2. Okay. There can be multiple such of these, and I do not wish to suggest that average is the only aggregation that we'd use here. For example, you might use count if you wanted to look at department size information, ordering by different departments. You might have sum if you're looking at sales figures, sums of salaries. So any of the aggregation operations is potentially relevant in this type of query. Okay, and again, I don't want to say that this is the only use of it, but it is the predominant use. It's the most likely you're ever going to see in your career. It's the most likely you're going to see in this course. Okay, now let's look at the second type. The where predicate. We have a condition. Okay. There are 4 broad categories of this. There are scalar subqueries, and there is membership in a set subqueries, there is existence of a set subqueries, and there is this broad naming convention that is used, and you will experience, it's a syntactic use, but it's unclear if it's useful beyond that. So we'll start with the scalar subqueries because they are the easiest form to understand. Suppose we have a query that produces a single value, and we've already seen one of these. This query produces a single value. Select average salary from instructor. Now, it's technically wrong to say it produces a single value. It actually produces a relation, but that relation has a single row and a single column. So something like select count ID from instructor produces a single value, the number of instructors. Okay. That's going to come out as, let's move up here, select count ID as num inst from instructor. This would produce num inst And then however many instructors there are. Let's say it's the University of Waterloo. It's something like 12 or 1300 instructors. We can treat this, instead of as a relation, we can treat it as a number. Okay. Treat it as a number. So, suppose we wanted to find out which professors have salaries higher than twice the average salary. We could do that as two queries. Okay. Select average salary, ... and that gives us a number. Let's say it's, I don't know, $28,463. Then we do select name and salary from instructor. Sorry, let me make that a little more readable. Select name and salary from instructor, where salary greater than 2 times 28462. Now that would work, sort of, except there's a problem with it. You have your client that is sending commands to your database, and so first you get the 28, whatever it was, 28,000, and then you have a second query. This is inefficient. Okay? This is particularly inefficient if this is a network, and in particular if it's a slow network, or if instead of being a single number we had lots of data going back and forth. This is undesirable. Okay? We would like to be able to combine them into the two queries. So we combine them by allowing this as a subquery, and it produces a single value. Okay? Now, a few comments on that. How does the database system know that it has a scalar subquery? And the answer is, it depends. There are queries that you know will produce a single answer. For example, select average sal from ... This is going to produce a single number. There are queries that you know will not produce a single number. Anything that's got more than one column is absolutely going to produce more than one column in the result, so it's not a single number. Then there are some where you don't know. For example, select distinct something from whatever. This might produce a single value. A simple example, select distinct department name from instructor where department name equal physics. Okay, that's a little bit strange, but what if it was select distinct, and let me erase this bit. Select distinct dept name from instructor where dept name like phys. Does that produce a single value or multiple values? Well, if you have a physics department and all your other departments don't begin with P, then no, it'll only produce one answer. But what if you have physical education? Okay? We don't know. And we may only know at runtime. So whether or not the database allows a scalar subquery will depend on how particular it is about checking whether or not that is capable of producing more than one answer. Okay? And please understand that in a case like this, because this data could be added later, maybe you start your little university with a physics department and then only later do you add a physical education department, it would only be later that that no longer was a scalar subquery. Okay? So, some things could only be determined at runtime, some things would change from being scalar to non-scalar as a query. How much the database checks it, how effectively it checks it, your mileage will vary. It's one of the reasons why testing needs to be done in systems. Okay, let's consider the second category. This is the where-in subquery. This is testing for set membership. It is providing for a set operation. It's saying, does this, call this X, exist in this set here? Okay. It is in some sense equivalent to an intersection. Why do I say it's equivalent to an intersection? Well, whatever this is, it is a representation of a portion of the rows from some of the columns, a subset of the columns, for each row in this relation that occurs after the from statement. So we have our from statement, which represents a relation. So select something from whatever this is here, it is a relation, which means it's rows and columns. Okay? Where, now we're doing this thing, we're saying, let's call these columns A, B, C, D, where B, C in this subquery. Okay? That's effectively the same as saying, okay, for each one of these rows, we want something like an intersection between this relation and this relation. It's not quite an intersection, it's an intersection over a subset of the columns. Okay? So, not strictly intersection. Here's an example of the use. Let's find the courses that are offered in fall 2019 and winter 2020. By the way, you may notice that we've already done this with set intersection. You could also do it with predicates, simple predicates. You could say semester equals fall and year equals 2019. You could have, let me erase that. You could have after that, or semester equals winter and year equals 2020. Okay? So notice that there are many ways to do things. Okay? One of the things that I may well test you on is give me 3 different ways in which you can do a particular query, rather than just one way. Okay? And the reason for asking for multiple ways of doing a query is simply because there are different ways you will see in practice. Okay? So, how is this working? This is working with, give us all the courses that are offered in the fall of 2019. That's what this portion will do. And now we want this subquery. This subquery says, give us all the courses that are offered in the winter of 2020. And so what we're doing is we're saying, here's our outer query that gives us the fall 2019 courses. And please make sure that course ID is also a course ID in the winter. Notice this key point. These columns must match up. Go back here. These columns, whatever this subquery is, it's going to have 2 columns. Okay, select whatever. This has to match this, and this has to match this. If they don't both match, it's not accepted. Okay, so that's the where in. Now let's see an example of where not in, which is non-membership. So this is somewhat equivalent to set subtraction. If you remember, I said there was no intersect and there was no except in MySQL. The reason for that is you can provide intersect and exception by using subqueries. Okay. So not in fall courses in fall 2019, but not in the winter. So again, we find our courses that are in fall 2019 and make sure none of those courses are in winter 2020. So the subquery is winter 2020. So perhaps at this stage you begin to get an idea that the way subqueries are operating is think about what the subquery needs to provide and then think about its relationship to the query. Although life is never that simple because it goes much deeper than just a couple of subqueries. So our third category, existence subquery. This is simply testing whether or not a set exists. Now these can technically be used in any category, but they are typically used in what is called a case of a correlated subquery. I'll explain what that means in a minute. Let's start with our example. Find courses offered in fall of 2019 and winter 2020. So this is, let's find a course that exists in the fall of 2019. Okay. And these will say section S. Sorry, wait a minute. This should be exists, not exists. Apologize for that. Okay. Fall of 2019. Okay. We want to know, do they also exist? Is this course also offered in winter 2020? Well, they are if and only if we have the same course ID in winter 2020 as in fall 2019, because this is the course ID. Okay. So please find those courses, and you notice at this point we don't care what this is. Why? Because we're simply finding, is the set this or is the set got data in? And we don't care how much data. 1 element, 1 million elements, we don't care. So we don't care what the contents of this is. We're simply saying, find me courses, every piece of information about courses that are offered in the winter term, and this is the key point, this is what makes it a correlated subquery. This course from section T has the same ID as this course. This is from the outer query. Ooh, that's nasty. Let's go back and look at this for a second. This query, not in, or this query, in, doesn't matter. Both of those queries, you can imagine them operating as, let's compute the inner query, and then we'll compute the outer query, and while we're doing the outer query, we simply check these as we go. Is this in there? Or is this not in there? we can do them separately from each other. We can do all of the inner query and then we can do all of the outer query. But in this case, we can't because they're connected. So what's going on here? Let's think about this. Here's conceptually what's going on. We've got the outer query. Section as S, okay? And it's got a course ID. We don't really care what else it's got, but it's got a course ID, okay? And these are courses that are all in fall 2019. So we've got course 1, 2, 3, and 4, 5, 6, and 7, 8, 9, whatever the course IDs are. As we produce these one at a time, we then have in our correlated subquery, and this has lots of columns in a sense, except it doesn't because we haven't created it. We can't create it because this requires t.courseid equal s.courseid. Okay? So we can't create this table without knowing what's in this table. So let's imagine we create this first row. Well, we can't entirely create the first row. Why can't we? Well, because this row depends in part on this and exists. Okay? So as we create the first row, we say, here's section, and it's got course ID and name and whatever else it has. So we look at this row and we say this one's in spring of 2018, so we don't care about it, reject it. Then we look at this one. This is in fall of 2019. Okay. So we've accepted it so far. But now what we do is we take this course ID and conceptually we go up and we say, okay, we know what this course ID is. So let's execute the little bit of the subquery that says select star from section as T and say this needs to be winter 2020 and course ID needs to match this for this row. Now, conceptually, you can imagine it creating the full relation here. Maybe this course is offered in multiple sections in the winter. But we don't care. All we need is one section. Either there's no section or there's one or more sections. So what is going on is as we evaluate each row here, we're able to see whether or not this set exists. And that is why it's called a correlated subquery. Lest you think that is sufficiently complicated, we're now going to get into one that's significantly more complicated, although still relatively simple. To give you an idea, real-world SQL has many tens of tables and joins within them, okay? Many tens of subqueries, in effect. So this is still relatively simple. Sorry to say that. Okay, so let's look at a not exists. So apologies for this, that not shouldn't be there. That was a where exists. Where not exists, okay. Find all students who have taken all courses offered by biology. Okay, sounds plausible. So, student ID, because this is student as S, and the student name, okay. So we want those students where there doesn't exist a course in biology that the student has not taken. So this is courses in biology And the student has not taken means another not exists, okay? So we want students for which there doesn't exist a course that the student has not taken it. So this is the determine whether or not a student has taken a course. This is the course that the student might have taken, course ID, and the student ID has to match. So notice SID is matching here, so we've got correlation between the very outer and the very inner. And we've got course ID here from the mid one and the innermost. Okay. If you want a motivation to learn relational algebra, it is much, much simpler to solve a case like that, because all you have to do is identify all courses that are taken in biology, that are offered in biology, and then you identify all the students who have taken all the courses that students have taken, and you divide the second set by the first set. So it's a much, much simpler query. Okay. Final portion of the where clause, any, all, and some. You will see these showing up in queries. Okay, remember I said there are scalar subqueries. In fact, I think it was around page 5. Yeah. There are two variations besides a general relation, okay? A general relation has rows and columns. We could have a relation that has a single row but multiple columns. We could have a relation that has a single column and multiple rows. And then we can have what we call the scalar, which is single row, single column. Now, first up, in the scalar subquery, I didn't mention this. You may have not noticed it. You may have noticed it. A subquery that produces a single multi-column row, that can also be compared. Okay, so you would have where whatever the columns are, and then a comparison operation. Equals, not equals, greater than, comparing to this single row query. Okay, that's a single row subquery. What we're looking at here are all categories of what are called single column subqueries. You have the column from your relation. Okay, so salary in this particular case, okay? And you do a comparison, and you have all in here with the single column subquery. So, for example, select whatever from wherever, where whatever column we're looking at is greater than all in the subquery. So, select name and salary from employee where the role is manager, because we want to find managers whose salary is lower than every senior technical staff member, STSM or STS. Okay. So give us the managers, and their salary is less than, what are the salaries of employees who are STM? Okay. Now notice, this is a single column query, and we're doing a comparison to it. What type of comparisons can we have? We can have equal, not equal, greater than, less than, greater than or equal to, less than or equal to. Okay, we'll start with the greater thans and less thans. And I won't bother with the greater than or equal to or less than or equal to. If I have a column and I have greater than all of this column, that's equivalent to greater than the max of this column. Okay. So this is a syntactic convenience to avoid having to do a max calculation over this. If it's less than, it's less than max of whatever. Okay. If it's equal to all, that's going to be a problem. Okay. How can something be equal to everything in a column if there is more than one item in the column? Then the answer is it's going to be false. Okay. If it's not equal to all in the column, that becomes slightly more interesting. Not equal to all should mean it is disjoint from every possible member in there. That is more than syntactic convenience. Okay. Or is it? How about not in? The reason for the comparison with all is it takes all of these different things and produces a single syntactic form. Okay? So, this is syntactic form, but it's a single syntactic form for a lot of things. Let's look at any. So all is, the comparison has to satisfy all of the single column subquery. This has to satisfy any in the single column subquery. Okay, sort of. Slightly more complicated. So let's imagine where we say select whatever from wherever, where column X is greater than any, whatever the single column subquery gives us. This is effectively greater than the minimum, okay? Because as long as we're greater than the minimum, we will be greater than any. So find managers with salaries lower than some senior technical staff member. This would be less than max, okay? Again, simplifying the terminology. Less than any. Select salary from employee where role equals STSM. That's a bunch of salaries for STSMs. This says the salary has to be less than any of these. Cool. Nice. We find some low-paid STSM, and here's the salary, okay? This manager is a low-paid manager, but he is higher paid than this poor little STSM. Okay. So this is roughly speaking equivalent... a special variation. In and equal to any is roughly speaking equivalent to in subquery. Okay. The membership. Not equal all is roughly speaking equivalent to not in. Okay, I say roughly speaking, there are some edge cases that make them slightly different, so they're not completely identical. The sum keyword is strictly speaking unnecessary. It is literally just an alias for the any keyword. Okay, it is only used, technically it can be used anywhere that any is used, but it is only in practice used for the not equal notation. And the reason has to do with the following. When we say select something from somewhere where column X not equal to, if it was any, most people will read that in English as long as this doesn't equal some value here, then that is true. That is not how the SQL syntax works. The SQL syntax works as there is no B which is equal to an A. The problem is that English and SQL notation differ, or the interpretation of the natural English and SQL differ. So the reason for the use of the word sum is it becomes much more readable in English. So the column is not equal to some value, okay? there is some b to which a is not equal, okay? Because it's technically not equal to any b. There's any b in here that this is not equal to. Not a is not equal to any b. I know that sounds a little bit confusing, but the summary is if it is a single column subquery that has more than one distinct entry, then not equal to some will always be true, okay? Because there will always be a b that is not equal to a, because if there's more than one thing, if a is equal to one of them, it's not equal to the other. So just to clarify, not equal to some is not at all the same as the not in subquery, okay? This is a fairly rare usage. As I said, if I want the not in, that's the equivalent to not all, okay? But you may come across it, and I wanted to make sure that you knew about it. This now brings us to the third of our subquery categories, the select from subquery. So please recall that what comes after from is a relation. Now, you're used to the idea that we have select something from and then some table name. It doesn't have to be a table. Anything that results in a relation is fine here, okay? The columns that are selected obviously have to be within that relation, but any form of relation. So a table name is a form of a relation. A table is a form of a relation. When we look at joins, you will find that joins result in relations, joins between tables, joins between relations, if you will. But another form of relation is a subquery, and a query, if you like. Every query results in a relation. Okay, so we can put a subquery there. So let's think about an example. We want to find the fewest number of instructors in a department. So if we think about Waterloo, ECE has 95-ish instructors, CS has a similar number of instructors, and then we've got some other areas that have far fewer instructors. If we look over at pure math, I'm not sure, but it's probably low double digits or maybe even single digits. If we look at some of the areas over in environmental studies or in arts, they'll be low. Religious studies is probably relatively low. Various of the languages are low. Knowledge integration, things like that. So we might have something that has very few instructors, and we'd like to know what is the fewest number of instructors that are in a particular department. So in order to know this, we need to know how many instructors are in each department. Now, generally, we would not keep that data in a base table. If you look at the department table, a department table would have things like an ID, a department name, if you will. It'll have information about what buildings it might possess, what budgets it might have, but it will not have information about how many faculty members are part of that department. And the reason is we will have an instructor table that'll identify instructors, and it will identify what departments they belong to. So this department ID will be this. So maybe it's physics or chemistry or whatever. Okay. And the reason we don't have a number of instructors over here is because whenever we change the data here, we hire a person, somebody retires, whatever, this number would immediately be wrong unless it was updated. And updating it is irritating and error-prone unless it's done in an automated fashion. And we can just extract it from here just by counting the number here. That's what databases are good at, or one of the things they're good at. Okay, so there's no point in having that information here. It's implicit information here by how many instructors we have. So how can we find out? Well, it's a standard aggregate query. Select the department name, the count of instructors, okay, and then group by the department name. That will take the instructor table and reduce it down to something that amounts to department name and num instructors. So there we have that. So we'll have physics 33 and chemistry at 20 and whatever else the numbers are. Okay. That doesn't give us the minimum. Well, that's okay. We can do select minimum from that because we know how to do that. Okay, 2 points that are important. Well, one that's very important. First, the subquery has to be given a name. Okay, I mention that because you will have a hard time debugging these queries if you do not give it a name. That's one of the SQL syntax errors you will have. Okay, must be given a name. The second one, you can't get the department name from this query because this is an aggregate query. And so we can't use aggregate data and non-aggregate data together. So how can we get it? Well, this is our above query. Okay, this is essentially that. It gives us the minimum number of instructors. And then we simply replicate the inner query, give us that table that contains the number of instructors, and please make sure that we only select the row that has the minimum number of instructors. Now, I would point out in passing, this is actually slightly nice, because if there's more than one department with a minimum number of instructors, it will list them all. Okay. It's also slightly horrible because there's the query and there's the same query, and we've had to specify the same query twice in effect. Okay, this one allows us to extract out the information, and this one then pulls one value from that. Okay, this reduces our instructor table into a department and instructor count. This pulls out the minimum, and this says, let's create that table again and just have that one value. Repeating the query twice here and here is kind of horrible and error prone. So, can we do something about it? And the answer is we can. This is our final form of subquery, the with category. Okay. The with category allows us to specify a query or many queries. Okay, with A as select, comma, B as whatever. And then we have the query that we want. Okay, so we can have multiple definitions. And the second point is, although I've given the column names here, if we're happy with the column names as they come out here, then we don't need to duplicate them here. Okay, so those are options to consider. But now we'll look at this specific situation. We want to do the same thing as we did here. Okay, we would like to find the department name or names, if there's more than one department, that has the fewest instructors. Okay, so this gives us the query that produces the temporary table that is instructor count. And it'll be name and count. And the reason I don't use COUNT is that's a keyword, and whether or not I'm allowed to, it would be a really bad idea to use a keyword, even if I could. Okay, so we've got physics, however many, etc. That's what this query will produce when it is executed. This simply defines the query, okay? This is where we use it, and we say select name and count from instructor count. That's the first use. Okay, here, where the count equals, give me the minimum count from instructor count, and that's the second use. So instead of having to write the query twice, we write it once, we give it a name, and then we use it. Okay, is this like a subroutine or a procedure call, a procedure in SQL? Sort of, but not entirely. Okay, it is sort of insofar as we've defined this query and we've used it twice. Okay, you may define a query and only use it once. You don't have to use it multiple times. This is just an instance where it's particularly useful, but any of the other subquery instances you could use a with clause in order to do it multiple times. But it's not like a subroutine in the sense that this only gets to be used with this query. This is not a permanent query, as it were. If you want a permanent query, you need to look into views in the data description language. I have not covered those yet. That is the more advanced DDL. Okay, views as opposed to tables, and also stored procedures. Okay, both of those are useful for subroutines in a broader sense. And I use the word subroutine if you're thinking in terms of a traditional language. We do not use the term subroutine in this context. And that's it for subqueries in SQL DML.